Uh, Hello, Assalamu alaikum. My name is Sayyid Sabi Ahmed, and I've been teaching and I've been in this profession for the last 27 years in a row. And here I'm going to teach something about chemistry, the topic of chemistry I'm going to discuss over here. I've been affiliated with Top Notch School and College of the town. Now, in today's lecture, I'm going to discuss with about matter and its states. Though it's very primary. I mean, it is the basic you can say. But anyway, this topic is there in grade 10, in grade 9, and even in class 5 in science. You have to read about matter and its states, right? And I'm sorry, my voice is a bit disturbed due to throat infection. Now, it is a demo lecture. What is matter? Matter is any substance which occupies space and has weight. So, is any substance which occupies space and has mass is known as a matter. Now, whatever the substance which exists is a matter in the first place. Those subjects which exist as a matter, I mean, there are certain matters which you cannot see with your naked eyes. But if you, say, for instance, you're sitting in a room and you just look around in your room, you will see the chair will be there, the table will be there, the beds will be there, the crockeries will be there somewhere at your home. So these are all is a matter. These are all a matters. Why it is matter? Because those things actually they got the mass, and whenever you keep it somewhere, it will occupy the space. So, in simple word, I mean you can say any substance which occupies a space and has mass is known as a matter. Everything which you see around you is a matter, right? And there's something as well which is a matter, but you cannot see it. Take for example, if you cannot see air by your naked eyes, right? So you just for understanding, you take a tire without air filling it and pick it up. You will feel it is lighter. Then you start pumping air into the tire, and then you try to pick it up. You cannot because it will turn out to be heavy. That means the increase in mass was due to the air which you fill in, right? And the air occupied the inner space of the tire. So you can see air too, you cannot see air, but air is also a matter because air actually has mass and air occupies the space. In case of tire, you can see that air is occupying the space inside the tire between the wall of the tire and the weight, the mass is increase of the tire after filling the air. It clearly shows that it became heavier due to the presence of air in it. Now, secondly, you can take a needle. Needle is quite light. I mean, but when you put a needle on a table or on a piece of paper, you will see that the needle is occupying a space. Though not that much, but yes, needle is occupying a space. And when you put the needle in a physical balance pan, you will see the pan will actually incline and go down. It's showing that the needle too has a mass, though very nominal, but it has a mass, right? And it is occupying a space as well. So, what is matter? Matter is a substance which occupies space and has a mass. It can be anything which exists. It is around you, all around you. You can see it is all matter, right? So I hope it been clear to you, and I think so. Probably, if there is any ambiguity, but I cannot ask you because it is not an interactive session. It is just the recorded session, so it is you used to be a passive listener, and definitely I'm the one who is actually communicating the thing up. There are states of matter and how many forms the matter exists. There are three states of matter, which plasma we also consider it, but mainly there are three. That is solid. You can see the picture. The solid, its shapes are intact, fixed. Now then there is a liquid. Liquid is another state of matter, and you can see the liquid is dropping down on the floor, right? And it is occupying the space, right? And definitely this liquid has a mass as well. And when you take solid, solid is also, you can see it is occupying the space. And when you pick it up, you will feel the difference in mass. So it also has a mass and occupies space. That's when it has a matter as well. Now you can see over here the third one, the gas, the smoke is coming out of chimney, right? Now this smoke is a gas, and you can see this gas, the smoke is occupying the space, this was space in the sky, right? And when you take the smoke and fill it somewhere, you will see the mass of the cylinder will also increase, meaning that the smoke, which is a gas, also has a mass. So these three solid, liquid, and gases are the state of matters, and these three are basically the one which has mass as well, and it occupies the space as well. Though in some cases you cannot see air because we inhale air, during respiration, but during the first phase of respiration, that is inspiration, we inhale air, but we cannot see it. But that air definitely is occupying the space in our lungs, in our bloods, right? And it is reaching inside our cells, and it has mass as well. So I think so. Probably I made myself clear, and I'm once again very sorry. My voice is a bit, I don't know what to say, because I got a throat infections and a fever a bit. So uh, I hope you won't mind it. Now we are going to compare, what do you call it, uh, states of matter. We are going to compare the difference between solid, liquid, and gases, right? So let's see. The properties are, we are going to discuss the property over here, that is structure, packing of particles, movement of particles, shape, and volume. Let's see solid, right? The second one, the solid, you can see the structure, there is a picture. These rounded object is basically the particles of the solid, which we call it the molecules, right? So these particles of the solid are closely packed with each other, you can see it. There is very nominal, negligible space between these particles, and these particles cannot move freely here and there. So you can see this in case of solid, this when you consider the structure of solid, the particles of solid are closely and tightly packed, and they are arranged in a sequence in an orderly manner, and you cannot see any space, so they cannot move freely here and there, but yes, they can vibrate within their own position, right? Now coming to the second one, the liquid. You can see the structure of a liquid. These rounded in the circle is basically, this rounded blue in the circle is the particle of a liquid, the molecule of a liquid, you can say. And these particles are at a distance with each other. Their distance is greater than solid, but it is not that much. You might have studied magnet, and you know the rules that whenever you bring different poles of the magnet closer to each other, its force of attraction increases. But when you start you increase the distance, the force of attraction will decrease. So likewise, you can see in case of liquid over here, the particle is a bit far as compared to solid. So the force of attraction, the intermolecular force of attraction between the liquid particles are less than the particles of the solids. Now, inter means between, molecular means molecules. Force of attraction, intermolecular force of attraction. The force of attraction between the molecules is known as intermolecular force of attraction, and intermolecular space is known as basically the space which is present between the molecules or the particles. So you can see there is the intermolecular space is there, more than solid but less than gases, and it is not that far that intermolecular force of attraction gets finished. Now, intermolecular force of attraction between the particles and the molecules of the liquid is there but less than solid. And as there is a space, so these particles can move randomly here and there. I mean, with no regular arrangement. I mean, but will remain within the system, will not come out of the system. And and when you see the structure of a gas, now you can see the blue, the blue dots which is inside the circle is a particle of gases. And when you compare it with the structure of solid and liquid, you will see the particles of gases are at a very far distance as compared to liquid and solid, right? So it means that intermolecular spaces are greater in case of gases than in case of solid, liquid and solid, and therefore the intermolecular force of attraction is quite lesser than that of a liquid and solid, right? I hope I made myself quite clear, and you might have been able to understand what I mean to say. The packing of the particle, I mean the arrangement of the particle in solid, liquid and gases. Let's see, but though I explained it to you, the particles are tightly packed with each other. You can see this structure arranged in an orderly order. There is no intermolecular space, and the intermolecular force of attraction between solid particles are so greater that the particle cannot escape from each other's force of attraction. Now coming to liquid, packed closely together but not as tightly as in solid. No regular arrangement, intermolecular spaces are present, so intermolecular force of attraction is lesser than solid. Now come to gases, a space far apart from each other, so almost the intermolecular force of attraction is negligible or minimum. Now coming to the third property, in comparison between these three, that is movement of particles. The solid particles can only vibrate about a fixed position. Vibrate means it will move on either side from its mean position, right? But it cannot travel, though you can say so. So we're coming to liquid, as there is intermolecular spaces, so particles slide past each other and move from here to there because there is intermolecular spaces present in liquid. Now when you come to gases, you see the particles move freely at a high speed because there are not many spaces present, the large gaps are present between the particles of gases, so they can move freely at a high speed. Take an example, if you are driving a car and the road is congested, there are more cars on the road, so you have to drive it slowly in a proper way. But when the road is empty, you can speed up. So likewise is over here, in case of liquid, the road seems to be congested a bit because there is a space but not that much. But in case of gases, the road is all open for you, there is no car in it, so you can rush with a high speed. Now shape, as the particles of solid are basically tightly packed and arranged in an orderly manner, and cannot move from here and they just vibrate, so the shape of the solid is always same. It is fixed. Now there will be a pen at your home, right? Definitely. So you can see the shape of the pen is fixed, it never changes. From the moment you bought it, the size, the shape of the pen remains the same. Because its particles are closely packed, they're not traveling, they're not moving, they're just vibrating. So they cannot change the shape. Likewise, you might have seen a lot of solid things at home. There might be, lamp, there might be a table, there might be any crockeries or anything, you just name it, your box. These all got fixed shape and fixed size as well, because the particles cannot move. Okay, now coming to liquid. Liquid has no fixed shape. It takes the shape of the container in which we put the liquid. Now take for example a glass of water. Now when that water is in the glass, that water will occupy the shape of the glass, because the glass is the container of the water, and water definitely is liquid. When you pour that water in a jug, it will occupy the shape of the jug, because here the jug is the container, right? Remember one thing, that the particles are apart but not that much. The intermolecular force of attraction is lesser than solid, but it is there. So, the particles cannot move out of the system, and that's been the reason that it got fixed volume, fixed size, you can say. Now, when it comes to gases, as the particles are free, no check and balance, no force of attraction, so they are free to move. So they got no fixed shapes, and they take the shape of a container. You fill the gas in a cylinder, it will take the shape of a cylinder. You fill the gas or air in the tire, it will actually take the shape of the tire. Now coming to volume, as I mentioned you earlier, that the particles, the molecules of solids are tightly packed in an orderly manner. So the volume, the size of the solid is fixed, and as there is no space between the particles, so you cannot compress it easily. When solid comes. Now coming to liquid, its volume is fixed, as I told you, that because the particle's force of attraction is there. One particle is attracting another particle, because the space is there, but not that much, right? So if any particles want to escape the system, it is not possible. Other particle will pull it down to remain within the system. That is why the volume or the size, you can say in simple words, of the liquid, the volume of the liquid is fixed. And as there is not much space between the particles, though there is a space, so it cannot be easily compressed. Now you can see, take a glass of water, pour that glass of water in a big jug. You will see it will occupy the shape of the jug, but the volume of the water will remain the same. A glass of water will remain a glass of water. A liter of water will remain a liter of water. It cannot change into 2 or 3 liters. Now, let's come to gases. Now, in gases, there is no, fixed volume, as I mentioned it earlier. The reason for that, it is far apart, so it can move freely here and there. You just spray the gas in the room. You will say it will spread throughout the room, and you just put that gas in a container. It will compress into and be of that size. So it is easily compressible, because there is a space between the particles, so we can compress it. I hope I made myself clear over here. Now let's see. Now you can see, what do you call it? There is density. Density is basically, mass per unit volume, right? Unit means 1 over here. So the density is more, means the mass is more per unit volume. solid density is more than greater than liquid, and liquid density is greater than gases. Because in 1 centimeter cube, you say, or whatever it is, take it. So in 1 centimeter cube, the solid particles will be more as compared to liquid, and liquid particle will be more as compared to gases. So means more particle means more mass. So solid got more particles in the same space than liquid, so its mass is more than the liquid, so its density is more than the liquid. Liquid is basically, they got a space between the particles as compared to gases. So there are less number of particles when it comes to liquid as compared to solid. So that's why, its mass is a bit lesser than solid, so its density is lesser than solid. When we compare liquid and gases, so gaseous particles are far away, right? So there are very less number of particles of gases present within the same volume as liquid and solid. So it means clearly that the mass of the gases are quite less than liquid, so that's mean the density of gas is less than liquid and solid both. I hope I made myself clear over here. Now over here, the changes of states, right? There's 3 states of matter: solid, then there is liquid, then there is gas. Now when you start heating the solid, now listen, when you start heating the solid, the energy from the fire will go inside the solid particle, and that heat energy in the solid particle will convert into kinetic energy, and the particle will get energized, and they will start moving with a great force, and when they will start colliding with each other, so they will form a space between the particles. Now when the space is formed between the particles, that means the solid is changed into liquid. Solid is changed into liquid. So this conversion of solid into liquid state on heating is known as melting. This process is known as melting. Vice versa to this, if suppose you start cooling down the liquid, so what will happen? The energy of liquid particles will start reducing. And when the energy of liquid particle will start reducing, so their movement will reduce, and they will come closer to each other and will get tightly packed in an orderly manner. And then when it gets this way, so it is now a solid. So liquid on cooling converts into solid state, and this process is known as freezing. You put the water in your freezer, the temperature is quite low over there, so what happens? The particles will come closer to each other because the energy has gone by, and it will convert into ice, that is a solid. So it is known as the conversion of water into solid, into ice is known as freezing, or other liquid as well. Now coming to a relationship between liquid and the gases, right? When you start heating a liquid, you will see the heat energy from the fire will enter the liquid particles, and the kinetic energy of the liquid particle will increase. When the kinetic energy will increase, they will start moving here and there at a very high speed, colliding with each other and pushing the particles far away, right, from each other. That's mean when more space is formed between the particles, so now it is not a liquid, it converts into gases, right? So on heating, the liquid converts into gases, and this phenomena is known as evaporation and boiling. Though boiling is a bit different than evaporation, but then too, for here you can just take it this way. Now when you start cooling the gas, right? When you start cooling the gas, what will happen? The gas particle will start coming to closer to each other, because the energy has been lost. So when they start coming closer to each other, it will change its state from gas to liquid. It will become liquid. So on uh, cooling, the gas turns into liquid, and this process of conversion of gas into liquid is known as condensation. Right now, coming to solid and gas. Now, when you cool a gas, to very extreme extent, that gas converts into solid because the particles start coming together with each other, right? And it is known as this deposition, right? Now, when you start heating the solid, in some cases, what happens, generally, when you talk about general, so when you start heating a solid, it converts into liquid first, melting. And when you continue heating that liquid, it converts into gases, which is evaporation or boiling, right? But there's certain, so it means that whenever you want to convert the solid into gases, it will convert first into liquid, then gas. If you cool the gas, it will convert into liquid, and if you further cool the liquid, it will convert into solid. So the intermediate phase over here is a liquid. I mean, the solid will never convert into gas without converting first into liquid. The gas will never convert into solid before converting into liquid, which is the intermediate phase. But naphthalene, camphor, there are certain chemicals which is, which when you heat, instead of converting into liquid first, it directly converts into gases. Camphor, when you start eating camphor, camphor will not convert into liquid, it will directly convert into gas on heating, and this process is known as sublimation. I hope I made myself quite clear, and there is no ambiguity whatsoever in it. Now, I would like to say thank you to all of you. And really, it was, you might be, you definitely were a passive, listener, and it was not an interactive session. So whatever the questions might arose in your mind, you cannot put it to me. But anyway, I hope that you understood what I taught to you. Okay, bye. Take care of yourself. Have a nice day.